Well, greetings from Total Output Power Solutions. We are now in the operation of 210 megawatt simulator training. So in this chapter we will see some points about the operation. We have actually done some operation in the simulator. Last part also we have done some operations in the simulator. But before going further, I would like to highlight some of the things about operation. So we see what are the principles of operation. We just discuss about it. The principles of operation. The operations must be carried out with certain goals, milestones. The milestones may be such as hydraulic test, acid cleaning, cold rolling, hot rolling, etc. And these goals are to be decided before doing the actual operations. The operations to be done, maybe some are serially and some are parallelly, but they must be decided as per the goals, what your goals are, similarly, and milestones. So you can set for the operation whether it is to be done serially or parallelly. Now, as the fuel consumed during the startup before synchronization increases the heat rate, set the priorities for the starting and stopping of the systems. The priorities, when you decide, you should take this PERT chart into the means you can check up about the PERT chart. So check the state of the plant, then you can have some oil systems, auxiliary system, condenser system, turbo IC systems, and WT plant. All these operations can be done parallelly. Then when we reach at the third point, you can have integrity of the system, check the integrity. LOP and bearing gear systems, they can be put on. Governor system, that also can be put on. Generator cooling system, that also can be checked. So these are the parallel operations to be done. Then when you reach the fourth milestone, you can raise the vacuum, you can have gland steam, the turbine drains also you can operate, main steam line warm up also can also be done. After that, admits the steam to the turbine, raise the speed to 3000 and synchronize and load. So these operations, some are serial and some are parallel. Now before any operation is carried out, think about the parameters that may prove the operation. That is, in case of starting a pump, check the ampere meter, bearing temperature, pump pressure, suction level, pump flow, etc. These parameters you may check and think about these parameters. After starting the pumps, fans, etc., check the starting kick in the ampere meter of the motor. In case of big auxiliaries such as BFP, keep a watch on station load and inform the other control rooms or the other units also. For charging steam, water or fluid lines, open the drains and vents of the line or the header. Then open the isolating valves and charge the line or header with steam, water or fluid. When continuous steam, water or fluid comes out from the drains, close the drains. This procedure will eliminate the hammering in the lines or headers causing the damage. If there is water in the header and if the steam inlet valve to the header is opened, the steam going into the header gets condensed, forming a vacuum in the header and causes a severe hammering in the header. Now close the vents also when the steam, water or fluid comes out from the vents in a continuous manner. This procedure eliminates the possibility of air entrapment in the header, vessel or the pipeline. Now when you start a fan, it must be started on no load and hence its discharge damper must be kept closed. The vanes also must be at minimum position. The lubricating oil pumps must be developing the requisite oil pressure for the bearing lubrication as well as for the controlling of the vanes, that is control oil. The standby oil pump must start in the event of any problem in the running pump. The trials for this must be taken to ensure this. While starting any pump, keep always the discharge valve closed except for the operation of some pumps where minimum discharge pressure is required, as in case of CEP. Also the auxiliary oil pumps for lubrication and control, they must be running and developing requisite oil pressure. All pump or fan motors and lubricating oil systems must be charged from the GS cooling system for cooling of motors and lubricating or control oil. All starting and tripping interlocks for the equipment must not be bypassed but put in service before starting the equipment or the auxiliary. For charging an electrical board, the high voltage side should be charged first. All electrical operations such as raking in of the breakers etc. must be done with all safety precautions. Now, what should be the general sequence of operations for boiler light up? You want to light up a boiler, so what should be the general sequence? The first of all, you should do the electrical charging. Then you can establish the water cycle for GS water for cooling, and the water may be available to WT plant for demineralized water. Compressed air system, this also we can start once the cooling water is available. Service air and instrument air. The boiler drum, deaerator and condenser and UDT filling with DM water. Establishment of furnace draft, we can start ID fan, FD fan, -7 mm of WCL and FD air minimum 30% of the maximum continuous rating. Oil handling plant, this has to be also ensured. FO, LDO, igniter oil pumps with requisite pressure. Warm up oil guns at lower elevations, it means AB, CD, igniters and scanners, their readiness also to be checked. All FSSS system should be checked and ready for light up, and then the next sequence will be boiler light up. The electrical charging already we have seen in our last videos. All the electrical supply from is for the station is for the units is from the station transformer. Generally it's a 400 to 6.6 kV or 220 to 6.6 kV. The station transformer capacity is approximately 20% of the generating capacity. The supply may be changed over to unit auxiliary transformer after the unit is synchronized. The 6.6 kV station boards are charged by charging the station transformers from the high voltage side, 400 kV or 220 kV, whichever is the voltage of the transformers first. The isolators of the 400 kV or 220 kV side breaker are closed and then the breaker is made on. The incomers of the station boards are made on to charge the bus bars in the board. All the outgoing breakers on the station board are made ready and 6.6 kV supply is extended to the CHP, AHP and cooling water systems. The supply is also extended to UAT A and UAT B, that is the unit boards of 6.6 kV unit boards. Low voltage station service boards, they receive supply through the station service transformers from the station boards. The unit boards and LT boards, both the unit boards have two incomers each. The first one is the tie from the station and second is from the UAT 16 kV, 6.6 kV or 20 to 25 MVA. All the LV boards, low voltage boards, that is boiler board, turbine board, emergency board, they are also charged. Instrument air and service air compressors are LT auxiliaries so that they can be run after the charging of LT boards. Then the water cycle establishment. The river water pumps pump water for the whole requirement of water to the TPS. This water is pumped by the RWP and is sent to the WT plant where it is treated and stored and then made available as general service water. The general service water pumps for all auxiliaries cooling systems are started and all cooling water systems are charged. The overhead GS water tanks are also filled up. The tanks are provided so as to act as buffer in case the pumps trip or not available for some time. After the cooling water is available from the instrument for the instrument air and service air compressors, the compressors can be started and instrument and service air is made available for the operation of valves, automation, etc. From the WT plant, the DM water will be available now. The intermediate DM tank is filled up and DM makeup pumps can be started. There are two emergency DM tanks provided in case of failure of DM pumps. These tanks are filled by the DM makeup pumps. The unit drain tank, condenser and deaerator may be filled up with the help of DM makeup pumps by opening the respective valves. The cooling water system of the condenser shall also be started. Now the boiler drum filling. The vents of the boiler drum shall be opened for boiler drum filling. Also, the economizer recirculation valve must be opened before starting the boiler drum filling. Now by starting the emergency lift pump and making the circuit through for boiler filling through the riser tubes header drain, the boiler drum can now be filled up to slightly below normal level, that is 0.5 meters. Now the preparation for the cold light up of boiler. We are doing the cold light up of boiler, so the preparation of that how we do. Check and remove any foreign material from boiler. Ensure all manholes, access doors and openings in the boiler and ducting are securely closed. Remove any restriction obstructing the boiler expansion. Ensure furnace bottom upper water sealing. Check up and keep ready the fuel oil pumping and firing equipments and systems. Ensure correct functioning of all interlocks and protections of auxiliaries, dampers and valves. Ensure full closing of all desuperheating spray control valves. The boiler drum has been filled to slightly below normal operating level with properly treated feed water. The feed water tank should have been filled with water. Recheck items such as oil guns inserted and properly coupled. Check the gasket between the unions, all manual valves open and all control valves closed. Now to avoid the possibility of oxygen corrosion in the boiler, the use of undeaerated feed water with temperature less than 100 degrees centigrade is not recommended. Now ID fan inlet regulating vanes or dampers, they are in closed position during starting. Keep the FD fan discharge damper closed and regulating vanes blades in the minimum position. Now establishment of air cycle. It is assumed that the unit will be started with both FD fans and ID fans. If the unit is started with only one set of fans and air heaters, the corresponding dampers associated with the equipment to be kept open. Dampers associated with idle equipment should be closed. The ID fans are capable of developing drafts in excess of the furnace design pressure. Therefore, the operator must take care to establish and maintain an airflow path through the unit prior to starting the ID fan and prior to opening the ID fan inlet damper. The ID fan inlet damper must be kept closed until after the fan is started. This procedure will minimize the possibility of developing excessive negative pressure in the unit during the starting procedure. The operator must take care to maintain the furnace draft within safe limit at all times. He must be specially careful when the draft and airflow controls are in the manual mode. He must be alert at all times for all possible malfunction of automatic control equipment resulting in abnormal excursions in furnace pressure, either negative or positive. Check that the air heaters have been cleaned and prepared for service. Then an adequate means of extinguisher air heater fires is available and ready for use. Place the gas temperature probe intermittently for monitoring the furnace outlet temperature. It shall be less than 540 degrees centigrade till reheater is charged, and accordingly the firing rate shall be limited. The soot blowing equipment and the system is in the startup condition, that is all blowers retracted and main steam supply valve open. Boiler drum along with economizer is filled with DM water up to normal level by the boiler filling pump. The drum vents are open. All the drains of the boiler drum and economizer are closed. All boiler, superheater and reheater drains and vent walls are in open or the startup position. Now, initial firing precautions. To ensure maximum safety margin during startups, it is mandatory that at least 30% of full load airflow to be maintained for an air-rich furnace atmosphere. This preludes the possibility of an accumulation of explosive mixture in the event of poor or delayed ignition after the fuel is introduced into the furnace. High excess air through the air heater minimizes the dilution of combustion air by inerts and carried over by the air heater rotor. During startups, lighting off is done with the lower igniters and warm-up oil guns. Warming up can be accomplished with either the warm-up oil guns or the fuel oil firing. Note: to minimize the possibility of adverse visible stack emission, it is desirable to use the warm-up oil guns till you attain at least 35 kg per square centimeter drum pressure and 177 degrees centigrade secondary air temperature before firing pulverized coal. The saturated steam temperature rise must be limited to 110 degrees centigrade per hour. During all startups, the firing rate should be controlled to keep the maximum furnace exit gas temperature below 540 degrees centigrade as measured by the furnace gas outlet temperature probe until adequate flow is established through the reheater by cutting in the HPLP bypass. After rolling the turbine, the steam temperature and pressure rise at the turbine throttle should at all times be in accordance with the limits prescribed by the turbine manufacturer. Note: it is recommended that during initial start of a new unit, a relatively slow rate of pressure increase be followed in order to allow sufficient time for checking expansion movements and to permit the operators to become familiar with the characteristics of the unit and its auxiliaries. Once these characteristics have been established, subsequent startups may be made at the fastest rate consistent with maintaining the furnace exit gas temperature limitation of 540 degrees centigrade until the HPLP bypass is cut in. So now we are ready to start our simulator operations. We must keep it in mind that we may make mistakes somewhere, but the simulator is there to correct our mistakes and let us know the perfect operations to be carried out in the plant. So goodbye and wait for our next video where we will be doing actual operations on the simulator. So like, share and subscribe our channel Total Output Power Solutions. Thank you. The Total Output Power Solutions, every calorie reduction in loss is reduction in fuel cost, reduction in pollution, and it is increase in monetary gain.